Now let's move on to the next part of this topic, that is maps and models. Now what is a map? A map or a scale model represents an actual object which is similar in shape but different in size. A map contains a scale that indicates the ratio of the distance on the map to the actual distance. So the model of the map is similar to the actual model. So if A upon B is equal to C upon D, where A upon B is equal to K, that is the scale, and C is the distance or the length of a side on the map, and D is the actual length, then we can write length of a side on the map will be K times the actual length. Now if we talk about area, we can say area on the map is equal to K square times the actual area. And when we talk about volume, the volume on the map will be K cube times the actual volume. Now let's solve some problems based on maps and models. The first one, on a map drawn to scale 1 is to 2,50,000, a triangular plot of land has following measurements: xy is equal to 10 cm, yz is equal to 8 cm, and angle xzy is equal to 90 degrees. Calculate the length of xy in kilometer and also the area of the plot in square kilometer. Now let's draw the figure first. XYZ, we draw the triangle such that xy is 10 cm, angle z is 90 degrees, and yz as 8 cm. Now here the scale factor K is given as 1 is to 2,50,000. Now the length on the map will be K times the actual length. Now the length on the map is given as 10 cm. So we have 10 cm is equal to 1 upon 2,50,000 into its actual length. So actual length will be 10 cm into 2,50,000. But here we are told to write the answer in kilometer. We have in centimeter. How do we convert centimeter to kilometer? We divide by 100 into 1000. So we write this as 10 into 2,50,000 upon 100 into 1000 kilometer. Now we simplify this, we will get 25 kilometer. So we have the actual length of xy is equal to 25 kilometer. Now for the second part in this question, to find the area of the plot in square kilometer. Now on the map we have got angle z as 90 degrees and we have yz 8 cm and xy as 10 cm. Now to find the area of the triangle, we know the formula half base into height. We know the base as 8 cm. But do we know the height xz? No. So we need to find that out. That can be easily done using Pythagoras Theorem. So we have xy square is equal to xz square plus zy square. That is, xz square will be 10 square minus 8 square, that is 100 minus 64, which is 36. So xz is equal to root of 36, which will give us 6 centimeter. So we have the height or distance xz as 6 centimeter. Now area of triangle xyz will be half base into height, that is half into 8 into 6, which is 24 centimeter square. Now by formula we will get area on the map is equal to k square times its actual area, that is 24 centimeter square is equal to 1 upon 2,50,000 the whole square into its actual area. But this is again in centimeter square. We want the answer in kilometer square. So now we will divide by 100 into 1000 the whole square. So we write actual area as 24 into 2,50,000 the whole square centimeter square. We divide this by 100 into 1000 the whole square. On simplification, we will get 24 into 2.5 into 2.5 kilometer square. That is nothing but 150 kilometer square. So the actual area of the plot is 150 kilometer square. Now let's look at our next problem. Here we have a building. A model of a building is made to scale of 1:50. The height of the model is 1 meter. Calculate the height of the building. If the area of the land used for the building is 1600 meters square, find the area of the base of the model. If the volume of the model is 20 liters, calculate the volume of the building in cubic meters. Now let's take the first part. Here we are given the scale as 1:50. So we take K as 1/50. We know height of the model will be K times the actual height, that is height of the building. So we write this as 1 meter is equal to 1/50 into height of the building. So the height of the building is 50 meters. So we've got the first part. Now for the second part, we want to find the area of the base of the model. Now area of the base of the model will be K square times area of the base of the building. That is 1/50 the whole square into 1600 meters square, because we are given area of the base of the building as 1600 meters square. Now we simplify this, we get 1600 upon 2500, that is 16 upon 25, which is nothing but 0.64 meters square. So we've got area of the base of the model as 0.64 meters square. Now in the third part, we want to find the volume of the building, and that too in cubic meters. Now volume of the model is equal to K cube times the volume of the building, that is 20 liters is equal to 1/50 the whole cube into volume of the building. So we get volume of the building will be 20 liters into 50 cube. Now 50 cube will give us 1,25,000. So we will get the volume as 25 lakh liters. Now we want to convert this to meter cube. We know that 1 meter cube is equal to 1000 liters. So we divide this by 1000 to get in terms of meter cube. So we will have the actual volume of the building as 2500 meter cube. Now our next problem says, in triangle ABC, AB equals 2 centimeter, BC equals 2.5 centimeter and CA equals 3 centimeter. Enlarge triangle ABC with scale factor of K is equal to 2. Find the length of triangle PQR, the image of triangle ABC. What is the relation between the areas of triangle ABC and triangle PQR? Now let's draw a triangle ABC with the given measurements. AB is 2, BC is 2.5 and CA is 3 centimeter. Now we are told to draw a triangle with the enlargement factor as K is equal to 2. So in triangle PQR, we will have length of PQ as 2 into AB, that is 2 into 2, which is 4 centimeter. The length of QR will be twice BC, which will be 2 into 2.5, that is 5 centimeter. Now length of RP is equal to 2 into CA, that will be 2 into 3, that is 6 centimeter. So we have got the lengths of the three sides of the triangle PQR. Now area of triangle PQR will be K square times the area of triangle ABC, that is area of triangle ABC upon area of triangle PQR will be 1 upon K square, which is 1 upon 2 square, that is equal to 1 upon 4. So we have got triangle ABC is to triangle PQR equals 1:4. Now let's take our next problem. A triangle of area 12 centimeter square is transformed under enlargement about a point in space. If the area of its image is 108 centimeter square, find out the scale factor of its enlargement. Now here we are given area of the original triangle as 12 centimeter square and we are given area of its image under enlargement as 108 centimeter square. Now let K be the scale factor. Then we have area of the image is equal to K square times the area of the original triangle. That is 108 centimeter square is equal to K square into 12 centimeter square. So we get K square as 108 upon 12, that is 9. So K square is 9, so K is equal to 3, that is the scale factor of enlargement is 3. Now, let us look at this topic from the board point of view. This topic carries 3 to 4 marks in the ICSE board exam. There is one question based on this topic, mostly in section B. Where can you lose marks in this topic? Whenever you are solving a sum and you are proving two triangles to be similar, write down the test of similarity. Also, draw the figures everywhere in the solution. Even though they are given in the question, redraw them in the solution and in pencil only. Then, whenever we are solving proofs, it's better to write in statement reason form. And also, write down a corresponding reason to every statement. Now let's solve some board problems. We start with the March 2002 board question, which says, in the right angle triangle QPR, PM is the altitude, given that QR is equal to 8 cm and MQ is equal to 3.5 cm, calculate the value of PR. We are given the figure. Now, let's take the two triangles PQR and triangle PMR. In these two triangles, angle QPR is equal to angle PMR equal to 90 degrees each given. Also, angle R is equal to angle R, the common angle. So we have triangle PQR similar to triangle MPR by AAA test of similarity. Now we have these two triangles are similar, so their corresponding sides will be proportional. That is, PQ upon PM equals QR upon PR, which is equal to PR upon MR. Now from the figure, we know the value of QR is 8 cm and MQ is 3.5 cm. So we can find the value of MR as QR minus QM, that is 8 minus 3.5, which will give us 4.5 centimeter. Now we take QR upon PR is equal to PR upon MR, that is PR square is equal to QR into MR. Substitute the values of QR and MR. We get 8 into 4.5, that is 36. So PR square is 36, that is PR is equal to root of 36, which is plus or minus 6. But PR cannot be negative, so PR is equal to 6 centimeter. Now let's move on to our next board problem. Here, in the given figure, AB and DE are perpendiculars to BC. If AB equals 9 cm, DE equals 3 cm and AC equals 24 cm, calculate the length of AD. Now in this case, we have two triangles, that is triangle CAB and triangle CDE. We prove them to be similar. Angle C is equal to angle C, the common angle, and angle CBA is equal to angle CED is equal to 90 degrees each. So we've got two angles equal. So we can say these two triangles are similar by AAA test of similarity. That is, triangle CAB similar to triangle CDE. Now their corresponding sides will be proportional. That is, CA upon CD is equal to AB upon DE. Substitute the values. 24 upon CD is equal to 9 upon 3. Cross multiply. We have 24 upon CD is equal to 3. That is, CD is equal to 24 upon 3, which is 8 centimeter. But we want to find the length of AD. AD can be obtained by AC minus CD, that is 24 minus 8, which is equal to 16 centimeter. So we have got the length of AD as 16 centimeter. Now let's look at our next board problem, which is the March 2006 board question. Here we have, in the figure, PB and QA are perpendiculars to the line segment AB. If PO is equal to 6 centimeter, QO is equal to 9 centimeter, and the area of triangle POB is equal to 120 centimeter square, find the area of triangle QOA, and we are given the figure for this. Now let's look at the solution of this sum. Here we have two triangles, triangle AOQ and triangle POB. We will prove them similar. Angle AOQ is equal to angle POB, vertically opposite angles, and also angle QAO is equal to angle PBO given. So we have triangle AOQ is similar to triangle BOP by AAA test of similarity. So now the corresponding sides will be proportional, that is AO upon BO equals OQ upon OP equals AQ upon BP. That is 9 upon 6 is equal to AO upon BO. Simplify this, we get AO upon BO equals 3 upon 2. Now, area of triangle AOQ upon area of triangle BOP is equal to AO square upon BO square. Because of the theorem on ratios of similar triangles, we get AO square upon BO square, that is 3 square upon 2 square, which is 9 upon 4. So we have area of triangle AOQ upon the area of triangle BOP, but that is given as 120. So we write that down here, equals 9 upon 4. So area of triangle QOA is equal to 9 into 120 upon 4, which is 270 centimeters square. So we've got the required area as 270 centimeters square. Now, let's take the next board problem, which is the March 2007 board question. In the given figure, ABC is a triangle, DE is parallel to BC, and AD upon DB is equal to 3 upon 2. Determine the ratios AD upon AB and DE upon BC. Also prove that triangle DEF is similar to triangle CBF. Hence find the ratio EF upon FB. Also asked what is the ratio of the area of triangle DFE and triangle BFC. We are given the figure with us. Now we take two triangles over here. Which two triangles should we select? Triangle ADE and triangle ABC. we will prove them similar. Here angle A is equal to angle A, the common angle, and angle ADE is equal to angle ABC, corresponding angles, because we are given DE parallel to BC. So we have triangle ADE similar to triangle ABC by AAA test of similarity. Now we want to find the ratios AD upon AB and DE upon BC. So AD upon AB is equal to DE upon BC, which is equal to AE upon AC, because corresponding parts of similar triangles will be proportional. Now AD upon AB can be written as AD upon AB is AD plus DB. So we get 3 upon 2 plus 3, that is 3 upon 5. Now in the first part we also need to find DE upon BC. DE upon BC is nothing but AD upon AB, which will be equal to 3 upon 5. Now in the second part we are asked to prove triangle DEF similar to triangle CBF. So we take these two triangles. Angle FDE is equal to angle FCB, alternate angles, and also angle DFE is equal to angle BFC, vertically opposite angles. So we have triangle DFE is similar to triangle CFB by AAA test of similarity. Now we are also asked to find the ratio FE upon FB. That will be equal to D upon BC, because the corresponding parts will be proportional. But this ratio D upon BC is equal to 3 upon 5 from the first part. So we have got FE upon FB is equal to 3 upon 5. Now in the third part, we want to find the ratio of triangle DFE and triangle BFC. That ratio will be equal to D square upon BC square. This is because of the theorem on ratios of similar triangles, which is equal to 3 square upon 5 square, that is 9 upon 25. So the required ratio is 9 upon 25. Now let's look at the brain map of this topic. We have seen what do we mean by similar triangles, then the test of similarity, the basic proportionality theorem, and the theorem on the ratios of areas of similar triangles. Let's revise them at a glance. Similar triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. Then the test of similarity, we have three tests. The first one, SAS test of similarity. The second one, AAA test of similarity. And the third one, SSS test of similarity. Then we had seen the basic proportionality theorem, which says if a line is parallel to one side of a triangle, it divides the other two sides proportionately. We had also seen the theorem on the ratios of areas of similar triangles. It says the ratio of areas of two similar triangles is equal to the square of the ratios of their corresponding sides. And we have also seen maps and models. What is a map? A map represents an actual object similar in shape but different in size. So I hope you have understood this topic well. Practice this and score full marks in the board exam.